Okay, now I'm recording already. I'm recording. Okay. Baik. So just now we have learned this formula. Yeah, we have learned this formula about VRMS equal. Yeah, we learned the root mean square speed. Root mean square speed is like average speed for gas molecule. Yeah, we know that when temperature increase, the gas molecule also move faster. So the VRMS value also become higher. Okay, so not just the VRMS, not just influenced by temperature, it also influenced by mass of molecule. Let me just show you over here. Yeah. Okay. This video is a continuation of the part just now. Okay. So I hope that you already watched the video just now. Okay. This one. This is the equation we learned just now. All right. So yeah. I want to rewrite the formula again. VRMS is depending on the temperature, 3 kT over mass of molecule. Okay, we know that at higher temperature, the gas move faster. And also, other than that, it also affected by mass of molecule. Yeah, VRMS also affected by mass of molecule, isn't it? For example, like mass of molecule. But you see, the heavier molecule, okay, move slower. Move slower. Yeah, the bigger mass. Yeah, if compare a small molecule, a small gas molecule with a big gas molecule, which one move faster? A small one and a big one. Which one move faster? Of course, this one. The VRMS. This one is smaller. Yeah. No. The one with a small mass move faster. The one with a big mass move slower because heavy. Can you listen to my sound? Can? Boleh dengar ke? Boleh kan? Okay. Yeah. So thank you. Yeah. So the heavier one moves slower, yeah, all because of this formula. So VRMS depend on temperature, the speed of gas molecule depend on temperature, and also depend on mass of molecule. Okay, heavier one move slower. Okay, so it's that's why in the notes he's saying what VRMS is directly proportional to temperature. The higher the temperature, the faster the gas move. But inversely proportional to the mass. The bigger the mass, the slower the gas molecule, the slower. Yeah? Lighter molecule move faster. Heavier molecule move slower. Okay, that's all. Now, next, we already learned about root mean square speed, right? We already learned about root mean square speed. Gas molecule, they all have velocity, right? Each of them have their own am I recording? Yeah, I'm recording. I need to check because sometimes I didn't record, you know. Okay, so I'm recording already. Good. Okay, just to check. So we know that gas molecule, they all have velocity, right? Some of them move to the right, some of them move to the left, upward, downward, to the front, to the back. Yeah, so they have velocity. So class, I want to ask you, an object with velocity, has what kind of energy? It has what kind of energy? An object with velocity. Yeah, can somebody tell me? Kinetic energy. That's right. It has kinetic energy. So now these gas molecules, all of them, they have kinetic energy. Yeah, they all have velocity, so they all have kinetic energy. That's right. Yeah, they all have kinetic energy. So now we also want to calculate what are the kinetic energy owned by these gas molecules. Yeah. Can we calculate their kinetic energy? Since they all have velocity, can we calculate the kinetic energy? Yes. But we must learn several principles before we can calculate their kinetic energy. Understand? Because they have motion, yeah, they have motion, so they must have kinetic energy. Okay, so we need to learn several. That is the molecular kinetic energy and internal energy. So we go to the next part already. Yeah, we go to the next part. Yeah, this is the next part. 9.2. Molecular kinetic energy and internal energy. So we need to explain and use translational kinetic energy. Okay, these are the formula. Yeah. So some of maybe most of you, surely you are don't understand at all anything of this. Okay, right? So I also find it very hard to teach you this thing. Okay, so but I have a simple method to teach you. That's why our Google Meet session is very important. I want to record. Yeah. In fact, actually, all this knowledge I already posted in YouTube in previous years. Yeah. In older videos, you can find the same content also. Yeah. But I will reteach the whole same thing again. Okay. So maybe if you watch my older videos, you already know. Yeah. What is the simple method I'm going to teach. Yeah. So never mind. Reteach the thing again. So okay, so I'm not going to teach you step by step for this one. Okay, but there's the first thing I want to teach you is you must know about our intention is to calculate the kinetic energy of gas molecule. Yeah, because we know that every object with velocity has kinetic energy, so we want to find kinetic energy of gas molecules. Yeah. Of gas molecules. So first of all, you must understand about degree of freedom. Yes, we go to 9.3 first. Yeah, go to 9.3. Degree of freedom. So what is degree of freedom? So it is an independent mode of motion or independent ways in which a gas molecule acquire or store energy. Okay, so there are ways. We need to know what are the ways where the gas can store energy. Understand? So what are the ways? We have translational motion. We know that gas molecule has translational motion, it has rotational motion, it has vibrational motion. But the vibrational motion only exists at very high temperature, above 1000 Kelvin. Okay. What is the translational motion, rotational motion? Okay, maybe I show you my video. I need to show my camera lah. I need to show you my camera. Can you see my face, class? Can you see? Can you see my face there? Yeah. Okay. Good. So, I need to explain about this. Yeah. So here you can see both my screen and also my face, right? Can see both side, right? Okay, I think I need to I need to put it here like that. Yeah, this way. Yeah. Okay. So because I record this session, I need to make sure I'm recording everything, including my face. All right, good. Yeah. Yeah. So you can see, yeah. So just now we talk about yeah, you see the screen now, right? Okay. So we talk about wait, let me see. Let me check. Let me check. Okay. So you can see the translational, yeah, translational motion and rotational motion, yeah, translational motion and rotational motion. Okay. So what is translational motion? Yeah, translational motion. Translational motion. That means gas molecule can travel linearly or can have translational motion, and gas molecule also can have rotational motion. So I'm going to show you this one. Yeah. So let me. Okay. You see, yeah, class. Imagine this is the gas molecule. Imagine this gas molecule. So translational motion means it moves to the right, to the left, going upward, downward, going to the front, going to the back. Correct or not, class? Alright? So translational motion means going x, y, z component. Yeah? Going. But we know that gas molecule does not just move in translational motion. It can also have rotational motion. As it moves to the right, maybe the gas molecule is rotating. It is rotating. Understand? Maybe it's moving, going up rotationally. Maybe it's going like this way. Maybe it is going from the back to the front. Can you see my camera, class? Can you see? Give a thumbs up if you can see. Good. Yeah. So gas molecule does not just move like this linearly without any rotational motion. Gas molecule can rotate as it moves to the front. As it moves to the back, it rotate. Maybe it rotate like this. Maybe it rotate like this. Maybe it rotate like this. See that? There are different ways it can rotate. So gas molecule, okay. I want to close my camera already. Turn off my camera. All right. That's why I say gas molecule has translational motion and also rotational motion. It can rotate when it moves to the right or to the left, move up or move down. So it can have translational and rotational. Okay, so am I recording? Yeah, I'm recording. Yeah. So also vibrational. Vibrational is only at high temperature. The molecules just vibrate. Yeah, the molecules just vibrate like this. You see, like you see vibrational motion, because two molecules they vibrate. Yeah, at high temperature they tend to vibrate. Yeah, with each other. But in our syllabus, we don't learn about vibrational motion, because we only learn at low temperature, below 1000. We don't learn at high temperature what happened to gas molecule above 1000 Kelvin. No, we don't learn at high temperature. So our syllabus just stick to 1 and 2, translational motion and rotational motion. Okay. So the number of degree of freedom depends on whether the molecule is monoatomic, diatomic, or polyatomic. Okay. So what is these figures? I will tell you about this. Yeah. I will tell you about that. So degree of freedom. First, I want to talk about degree of freedom. What is actually degree of freedom? Okay. So let's look at this. What I'm going to show you over here. Degree of freedom is like, ways in which the gas molecule can store energy. It's like partition. Partition in your laptop or your hard disk. Let's say let's look at my hard disk. Like my hard disk. My PC. Can you see my PC, class? Can you see my PC, my partition? I have C drive, I have D drive, I have E drive. C drive, I put 280 gig. D drive, I put 100 gig. Actually, C drive, I put 300 gig. D drive, I put 100 gig. And for E drive, I put 100 gigabyte. So total, I have half a terabyte for my entire hard disk. Half a terabyte. That means 500 gigabyte. 500 gigabytes. So I divide into 300, 100, 100. So it's like, it's like my C drive, my C drive. I divide in the ways I divide. Okay, I divide into 3 parts. This is my D drive. This is my E drive. Okay, my D drive, E drive, C drive, my C drive, C drive, E drive. So this one, my C drive, I put 300 gigabyte. This one I put 100 gigabyte. 100 gigabyte. So we consider this is my storage. Like I can say my storage, my total storage is 500 gigabyte. Okay. So I can say these are the degree of freedom. I have 3 degree of freedom. Okay. So my degree of F is the symbol of degree of freedom is F. Let's look at it. Degree of freedom is F. So degree of freedom. So how do I store my data? How do I store my data? I have 3 degree of freedom to store my data. So we can consider this 500 gig is like my kinetic energy. Understand? It's like my kinetic energy. I consider this. Do you imagine this is like my gas molecules or the gas molecule, the gas, yeah, the gas. Consider this whole thing is like my gas. So this 500 gig is like my my kinetic energy, the total kinetic energy for the whole gas. And degree of freedom is the ways to store my kinetic energy. So my degree of freedom is 3. 3 ways to store kinetic energy. Understand? This ways is like my partition lah. This ways is like my partition. Understand? I have 3 partitions to store my kinetic energy. Understand, class? Okay. At least so that is what it means by degree of freedom. Degree of freedom is the independent partition. You can say like partition or independent ways, independent partitions in which a gas molecule can store energy. Okay, so how many ways to store energy? As I mentioned just now, molecule can move in translational motion, move in rotational motion, and also vibrational motion if very high temperature. Yeah, but we don't study about vibrational. We just focus on these two, translational and rotational. Okay, so if look at here, translational motion. Okay, so let's talk deeper into translational motion and rotational motion. Okay, so now go to this is one simple ways to explain about ways to store kinetic energy. So let's look at the gas molecule. Okay, in more detail. So we know that it's stored in okay, translational, rotational motion, okay, and vibrational. So we can consider this like the partition of kinetic energy where the gas molecule can store. That means this what they can store kinetic energy in the form of translational motion. They can store kinetic energy in the form of rotational motion. They can store kinetic energy in the form of vibrational motion. This one if this one temperature above 1000 Kelvin. But we don't look deeper into this one. Yeah, we don't look deeper. We just we don't study above 1000. Yeah, so we just look into these two. Okay. It can store kinetic energy in translational and also rotational. Remember the formula we learned before? In translational motion, we learn kinetic energy is half mv square. But for rotational motion, the formula is almost the same. It's half I omega square. I think maybe you don't learn about half I omega square because this one is in all syllabus. All syllabus we learn this formula, half I omega square. Mass is like moment of inertia. Velocity is like, angular velocity. So we have half mv square for translational motion. We have half I omega square for rotational motion. So half mv square is energy for translational motion. Yeah, move left, right, up and down, forward, backward. Rotational motion is, turn clockwise, anti-clockwise. Okay, let me draw it out. Yeah. Translational motion is for going left, right, left, up, down, forward, backward. Your x, y, z component. Rotational motion is you have turning clockwise, anti-clockwise. So the for translational motion you have velocity v, rotational motion you have omega, isn't it? Angular velocity, turning anti-clockwise, clockwise. So gas molecule can store energy in these three forms. If above 1000 Kelvin, can store as vibrational also. Low energy can store in translational motion and rotational motion. So now we look deeper. In translational motion, also divide into three partition. Because we know that translational motion has X component, has Y component. Actually, it also has Z component. Oh, actually, I'm wrong. I should put it this way. This one should be the Y, X, Y, Z. Class, you only learn about X and Y, kan? Correct or not? All this while you just learn two-dimensional, kan? You just learn two-dimensional projectile. You just learn two-dimensional projectile motion. You just learn two-dimensional conservation of momentum. Two-dimension conservation of momentum. All things you just learn two-dimension, kan? Actually, you have three dimension. We live in three-dimension world. Do you know that? We live in three-dimension world. It's not just two-dimension. You resolve vector. You resolve vector also only to two dimension. That means you only have X and Y, kan? You only have X and Y direction. But actually, you need in unity. If unity, actually you need to resolve vector into three dimension. Do you know that? In metric we just simplify into two dimension, X and Y. But actually it's three dimension. Actually it's three dimension. You have X, you have Y, you have Z. What is Z? You already learned about X and Y. X and Y means going to the left, right, left, up and down. But the object also can move in three dimension. That means can move to the front, to the back. Move to the front, to the back. That is Z. You haven't learned how to resolve vector into three dimension. You just learn about X and two dimension only. So of course now we don't suddenly teach you three dimension. Very complicated. So we teach you two dimension first. Then when you go to university, you start to learn three dimension. But now we need to touch about three dimension also. Because we need to know about the degree of freedom where the gas molecule can store kinetic energy. Okay, so actually it has three dimension, X, Y, Z. Okay, so the gas molecule can like I showed you before, the gas can move to the right, to the left, up and down. Some gas molecule move to the right, some gas molecule move to the left, some molecule move up, move down, some gas molecule move to the front, to the back. So you can see the gas molecule can store energy in three ways. Understand? It can store energy in three ways. So below translational motion, you have three partition. You have three partition. X, Y, Z. You have three partition. So you have three partition of energy. Three partition where they can store kinetic energy. Can store kinetic energy in X, can store kinetic energy in Y, can store kinetic energy in Z. That means because we already learned the assumption before, kan? We did learn, where is my notes? Back to our assumption of gas molecule, kinetic theory of gas. Where is it? See this one, the assumption of gas molecule. All molecules move randomly. Move randomly. That means it move in any direction. Move in any direction means we can move in X direction. Some molecule move in X direction, some molecule move in Y direction, some molecule move in Z direction. So they can store energy in three ways also for translational motion. For translational motion, the gas can store kinetic energy in 3 ways also. Because they move randomly, move in all direction. Understand? Now, gas molecule not just move in translational motion, left, right, up and down, back to the front, to the back. It also move in rotational motion. I show you already just now, kan? The gas molecule can rotate as it move left or right. It can rotate also. And the ways it rotate also has 3 dimensions. Understand? The ways it rotate. Let me show you, class. Let me show you. Maybe I should show you my face again. Yeah, show you my face. Can you see my face, class? Can you? Yeah. See, just now I talked about translational motion has 3 ways, kan? Can move to the right, to the left. This is X component. Can move up and down. This is Y component. Can move to the front, to the back, to the front, to the back. This is Z direction, Z, yeah, Z component, to the front, to the back. Okay, but it does not just move plainly like this. The gas molecule can rotate, Understand? In rotational motion, also store kinetic energy. Okay. So you see, the ways gas molecule can store energy. You see, there are 3 ways that this molecule can rotate. 3 ways. One way is it rotate like this. Okay, sorry. One way is it rotate in you say X component. You rotate X component means it rotate like this. That means using the X-axis. Using the X-axis as the axis of rotation, it rotates like this. Understand, class? Understand? So that is one component. Using the y-axis, y-axis as axis of rotation, the molecule can rotate like this. You understand? Using the y component, using the y-axis as axis of rotation, the things can rotate like this. Using the z-axis as axis of rotation, the things can rotate like this. See that? So there are 3 axes of rotation. 3 axes of rotation, so you have 3 degrees of freedom for rotational motion also. You can rotate like this. You can rotate along this x-axis. You can rotate along the y-axis. You can rotate along the z-axis. Understand? You can rotate like this. You can rotate like this. You can rotate like this. You see, you can rotate like this. You rotate along the x-axis. You can rotate along the y-axis. You can rotate along the z-axis. Rotate along the x-axis. Rotate along the y-axis. Rotate along the z-axis. Okay, class, do you get it? If you give a thumbs up. Get good, good, very good. All of you, very good. So let me where is the okay, that's all. That's all for my camera. I want to off my camera because once the camera is on, it is oops, I need to off my camera. Okay, make it bigger. Okay, can you see my okay, can see already, Okay, so let me show you the notes again. Let me show you the notes. Yeah, let me show you the notes. See the notes here. You say this thing can rotate along the x-axis, can rotate along the y-axis, can rotate along the z-axis. So can have 3 degrees of freedom also. That's why he said. That's why in rotational motion. Also has x, Y, Z. So and that means in below rotational motion have 3 partition also, and each component can store kinetic energy also. Understand? Vibrational motion also have degree of freedom, but we don't study. Right now we only study until maximum 6 degree of freedom. How many degree of freedom here? You can see. How many degree of freedom, class? Tell me. What is the maximum degree of freedom you can see over here? 6, right? 3 from, that means 3 from translational plus 3 from rotational. Okay? So 1, 2, 3, 4, 5, 6. So you have total 6. We can say for gas molecule. Okay, I want to say like this. We don't look at vibrational. Kalau ada vibrational lagi is more than 6, above 1000 Kelvin. But we make it our simple. We just learn these two enough, translational and rotational. Okay, no need to learn so much. Okay, so now for gas. Last time is just hard disk storage. Now for gas molecule, it can have 6 partition. How do you draw 6 partition? Like this. Like that. Am I right? Yeah, 6 partition. I'm so good. Yeah, 1, 2, 3, 4, 5, 6. So we have 6 ways to store energy. 6. So that means gas has 6 ways to store. That's mean by degree of freedom. 6 ways to store kinetic energy. Okay, 6 ways. All of you have 6 ways. Okay, now before we go any further, let me show you the monoatomic, diatomic, polyatomic later. Later I will talk about this. I want to go for equipartition of energy first. Equipartition of energy. So what is mean by equipartition of energy? The principle of equipartition of energy states that the average kinetic energy stored in each and every degree of freedom of a molecule is half kT. This is the most important one. 1 degree of freedom, how much energy is stored? Half kT. You understand? Half kT. Okay, later we look about this. Okay, so see the average kinetic energy stored in each and every degree of freedom of one gas molecule is half kT. This is the most important one. Okay, so that means how do we calculate the kinetic energy stored in this 6 degree of freedom? That means consider this is one gas molecule. One gas. Consider this is one gas molecule. Just one gas molecule. Maybe this is carbon dioxide. Maybe this is carbon dioxide. One carbon dioxide gas molecule. This is a polyatomic gas. Okay, you will understand why later I will talk about this. Why I use carbon dioxide? Why I don't use helium or hydrogen? Why I use carbon dioxide? You understand? Okay, consider this is one gas molecule. So it has how much energy it can store? It can have translational motion, it can have rotational motion, and each motion can have X, Y, Z, three ways. So all together have 6 ways. And here he said equipartition of energy. Equipartition. What is mean by equipartition? Principle of equipartition. The word, it tells you the meaning already. Equipartition of energy. What does it mean by equipartition? Okay? What does it mean by equipartition, class? let's say if I have a storage like this, I have a hard disk like this. If I want to divide 500 gig equipartition, equal partition. How do I divide? How do I divide? I divide by 3, isn't it? I divide by 3. So it no longer is 100, 100, 300. This is not equipartition. This is unequal. This is unequal. If I divide equally, how much is it? 500 divided by 3. What is it? It should store 166 gigabyte, 166 gigabyte, 166 gigabyte. Equipartition ma. Equipartition. So I divide equally. Understand or not? Equipartition means what? Equal parts. That means equal parts. Energy, you know why equal parts? Why energy is equal parts? Why is not, oh, let's say my kinetic energy, let's say my kinetic energy is 600 joule. Why not store more energy in X? Why not store more energy in Z? Why is store equally in each component? That means, let's say I have 600 joule of energy. That means it divide equally. It divide 100 joule, 100 joule, 100 joule, 100 joule, 100 joule, 100 joule. Plus, I ask you, why it divide equally? Why is not more? Okay, why is not more in X? Maybe 400 here. The rest is 50, 50, 50, 50, 50. Why is not more at X? Why is it equally in all? Why equal parts? Class, why? Why is it divide equally? Let's say this gas molecule has 600 joule of energy. Why is not, okay, why is not, this one is 400. The rest is just 50, 50, 50, 50. Yeah? Why is not like that? Why is it equal? Why the principle you say equipartition energy? Why is it kinetic energy stored in each degree of freedom is equal? Why is it equal? Why is not more at one part? This one go back to our assumption. Kinetic theory of gas. Remember what we learned in assumption of kinetic theory? All molecules move randomly. Move randomly means it move in any direction with any speed. That means gas doesn't just move all in X component. Gas move in all direction. So S component, Y component, Z component equal. Gas molecule move in all direction, random direction. Understand or not? We cannot say, oh, all gas move in X component. Gas move randomly, move randomly. Gas move randomly. So it doesn't all gas molecule, we cannot say most of the gas molecule move in X component or all gas molecule move more in Y component. No, they move randomly. They move in all direction equally. That's why he say it must fulfill the principle of equipartition of energy. That's why he say, where is it? That's why energy stored in each degree of freedom is equal parts. So that means you cannot say, oh, all the gas molecule move in X component, the rest move less. There are more molecules move in X compared to molecules move in Y and Z. No, that does not fulfill the assumption of kinetic theory. They must be equal in all parts because they move randomly. Understand or not? That means if I have 600 joule of energy, they divide equally. They divide equally. 100, 100, 100, 100. Understand, class? Understand? Yeah. Okay, now, surely you don't understand what is half kT, isn't it, class? Yeah. I take it step by step. I teach you bit by bit, enlighten you bit by bit. So you must stay with me for another 10 minutes. Yeah, just another 10 minutes, please, class. Yeah. I just want to sort this out, then we can end this video. Yeah. What is half kT? What is half kT? Half kT is a way to calculate the kinetic energy stored in 1 degree of freedom, for one gas molecule. Half kT is just a way for, because our intention is to calculate the kinetic energy of gas, isn't it? Because we know that a gas molecule with velocity must have kinetic energy, and we don't have a formula to calculate the kinetic energy, right? And what is half kT? Half kT is the formula. Understand, class? Half kT is the formula. What is T? What is T? T is the temperature lah. Temperature. If you know, class, if you know the temperature of gas, you can calculate the kinetic energy of gas molecule. Do you know that? You must know the temperature, but this temperature must be in Kelvin. Class. Later I will. Okay, so that means, class, consider this is one gas molecule, polyatomic. So that means this gas molecule has translational motion and rotational motion. So combine both, we have 6 degrees of freedom. Okay, and so we consider this gas molecule has 6 partition of energy. Yes, 6 partition of energy. And how to calculate the kinetic energy for this gas molecule of carbon dioxide? How? The formula is half kT. So okay, maybe I can redraw. Yeah. I think I need to redraw this one, put into here. Okay, equipartition of energy. Okay, so not 600 lah. 600 is just a a value I just give. Yeah, simply give. Okay, so this one, how to calculate the kinetic energy? How to calculate the kinetic energy for one gas molecule of carbon dioxide? It is this one. It has for each degree of freedom is equal half kT, half kT, half kT, half kT, half kT, half kT. That means this carbon dioxide gas molecule, it has half kT equal partition of energy. Each part store equal amount of energy. Why store equal amount of energy? Because it moves in random direction. Our assumption for kinetic theory, it moves in random direction. So each parts must have equal amount of energy. And half kT is the way to calculate the kinetic energy for each part. Half kT, half kT, half kT, half kT, half kT, half kT. So what is the kinetic energy for one gas molecule of carbon dioxide? So the kinetic energy for one. Okay, let me just write it out. Yeah, just write it out over here. Okay, so what is the kinetic? Okay, I must make this bigger. So many things I need to adjust, so many things I need to adjust. Okay, so kinetic energy for so many things I need to adjust for one carbon dioxide gas molecule is how many? How many degree of freedom? 1, 2, 3, 4, 5, 6. We consider like, for example, like this part is for translational, right? Not and then the other part, this part is for what? For what? Rotational. For rotational. Translational and rotational. Don't talk about vibrational. Okay, so it had the kinetic energy for one gas molecule. It has 6/2 kT. So the answer, how many? 1, 2, 3, 4, 5, 6. So it has 6 times 1 over 2 kT. So for one gas molecule, for one gas molecule, the kinetic energy is 6 over 2 kT. So if you know the temperature, you use this formula, you can calculate the kinetic energy for one gas molecule. Each degree of freedom store an equal amount of energy, half kT, half kT, half kT. Okay, I think that's end for our class. Yeah, I haven't teach you about this monoatomic, diatomic, polyatomic. Never mind, just a little bit more, you can understand the whole thing again. Yeah, you just learned for one gas molecule. Later, I'm going to teach you how to calculate for. Let's say you have one. This is just one gas molecule. Imagine if you have n. If you have n gas molecule, how to calculate? If you have n gas molecules, then how to calculate the kinetic energy? Just multiply n, isn't it, class? Just multiply n, isn't it? You get the kinetic energy for one gas molecule, you just multiply n, you get the gas molecule. So you see, I show you bit by bit. So, but for that, I will teach you in next class. Yeah. At least now you know about equipartition of energy means they have equal parts. Yeah. And the degree of freedom means ways for gas molecules to store kinetic energy. Yeah, that's the most important. And how they rotate, I will also show you through the camera. Yeah, they must have equal parts. Okay, understand, class? That ends our class for today. I'm going to continue for next class. Okay. Okay, any questions? Any questions? No questions? Everything's good? Okay. All right. So okay. So that's all for today. Yeah, I'm going to continue the class next time. Yeah, next class. Okay. See you. Bye.
Thank you, sir.
Okay.
Thank you, sir.
Yeah.
Thank you,
Okay.
sir.
Welcome. So I will post this in the YouTube lah. You boleh tengok semula nanti.